One of the topics that you are going to learn in magnetic field is the topic of electromagnetic induction. In this section of electromagnetic induction, something that you need to remember is that if a magnet is brought and is moved closer to the coil, these magnetic fields are going to cut through this coil, and this is going to result an induced EMF in this particular coil, hence current is going to flow. Or if you move a conductor in such a way that you move it downward, you pull it down into this particular magnet so that it can be able to cut this magnetic field, something that is going to happen is that as the conductor cut through the magnetic field, an induced EMF is created in that particular conductor, and then you can be able to predict the direction of the induced EMF using Fleming's right hand rule. And we need also to understand the concept of magnetic flux. And first you need to understand the definition of magnetic flux density, and in this case we're going to say magnetic flux density is the force acting per unit length when a unit through a conductor carrying a unit current which is perpendicular to the magnetic field. So it means that there will be no force produced if the conductor is not in a magnetic field, such a way that that particular conductor should be making an angle with the magnetic field. Then you need to understand about the magnetic flux. Magnetic flux is the total number of magnetic field lines which are cutting across a given area. And for you to calculate the magnetic flux, you are going to use the formula magnetic flux density times the area which is perpendicular to that particular field. But if the fields are making an angle with the area, then you need to find the magnetic flux by the formula, the magnetic flux density times the area times cos of theta, whereby theta is the angle between the normal of the area and the magnetic field. So having understood that, you need to understand the magnetic flux linkage, and the magnetic flux linkage in A level is going to be given by the number of turns or the number of coils times the magnetic flux. Now, having looked at that, you need to understand Faraday's law of electromagnetic induction, which states that the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. So which means that if you have the rate of change of magnetic flux, that is equivalent to the EMF induced. But the negative sign is telling you that if the gradient of this one is positive, it means the EMF is going to be negative. Or